All right, and I guess on that last video, I was attempting to rush it a little bit to get to fertilization. You might have noticed in that last video, I repositioned it, what's called Bartholin's up here. And I forgot to mention a couple of things. I mentioned essentially the clitoris is analogous to a penis in males. It just doesn't have a urethra going through it, but same spongy tissue, same type of nerve endings. The labia, they're analogous to essentially the scrotum in males. It's not unheard of. In fact, it's not really that super uncommon that you give birth to a child and the doctor says you have a girl, and after a little while, all of a sudden, her clitoris starts to enlarge, and all of a sudden, her labia start to enlarge, and something moves into the labia. The labia are essentially what would have been, well, not essentially, but they are what the scrotum would have been if she had ended up as, or if that female had ended up as a male. This Bartholin's, though, females will also have Bartholin's glands, and those Bartholin's glands are the equivalent of bulbourethral in males. So a Bartholin's gland is going to secrete lubricant into the vagina when there's stimulation. So Bartholin's, or is it bulbourethral, male and female? Labia, or is it scrotum, male and female? Clitoris, penis, male or female? So keep in mind, we were all set to be able to go male or female, depending on what chromosome, X or Y, that we ended up getting from our parents. Well, our dad. So now I can jump to the next part of this. So ejaculation has happened. The sperm have swarmed what's left of this follicle, and we need to take a look at what's going to occur next. So I want to look at this oocyte, this portion of the follicle that's been ovulated 14 days ago. And here's a drawing of it. Now, I should have set these up in a different order, but I think you'll get the idea. Remember, the rest of the follicle cells that were in the ovaries were left behind. They're now corpus luteum. This is what's been ovulated off or out of the side of the ovary and swept up into the oviduct. There's a little clear area right here called the zona pellucida, the lucid zone, the clear zone. It's going to be important. Then around the outside, all these follicle cells, this crown that radiates out is referred to as the corona radiata. If we go in further, there's the oocyte. I probably should have put primary oocyte. It's still stuck in prophase arrest. And if you look at the inside, there's a whole bunch of little dots, and those are called cortical granules. They're vesicles inside the cell. And they have a really important chemical in them, and you'll see what they do in a minute. Now, when we end up with sperm, let's say we've got 10 sperm out here, and they're using their acrosomes to try and digest their way through these cells to get to the egg. Once one of them gets to the egg, there's now some competition. You've got others. So you have to do something to make sure that you're the only one that does the fertilization. Another thing that I should have mentioned is this. That egg that's ovulated is viable for 24 hours. So as I hinted at in an earlier video, there's a very sketchy and very poor form of birth control where if you think about this and you go, okay, well, if the female ovulates and it's only viable for 24 hours, and the male ejaculates and that sperm is good for 72 hours, if they are able to avoid unprotected sex for 72 hours prior to ovulation, and then until 24 hours after, then you won't get pregnant. Yeah, you will. The human body is highly variable. If you end up ovulating 12 hours early and you're using that method, you're pregnant. If you end up ovulating 24 hours later, you're going to be pregnant. So I would highly recommend, if you're looking for a birth control method, that is not the way to go. Don't go with this rhythm method. But that's kind of the thought behind it. So let's take a look at what's happened here. We'll go back to this internal genitalia. Here's our little time lapse. We've now had our released cell, well, follicle, what's left of the follicle, through here. And I'm going to go back to this one for what I want to mention next. Keep this in mind. We've got, 10 sperm here. One sperm makes it in. Here's what happens next. First, you end prophase arrest. What we started out all these videos with is dealing with the fact that that oocyte, that primary oocyte, is stuck in prophase. Not anymore. So you've never completed a meiotic division, if you're female, if you have never had contact with a sperm to the point of fertilization. Prophase arrest ends. Now you end up with your haploid sperm. You know, end up, I can use the term haploid egg or oocyte. They're going to fuse together. We're back to diploid, back to 46, and we're off to the races. But to make sure that you don't have any competition, the first thing that's going to happen is what we call a fast block. And a fast block happens, as it says, very, very quickly, very fast. Sodium channels open. And these are sodium channels on now the egg. Well, at the time, it would be the oocyte. As the sodium moves, the charge changes. And it very quickly makes it less likely that a sperm is going to be able to fuse with it, because you don't want a second sperm in there. Suddenly, your numbers have gone from 46 to 69, and that's a failed pregnancy. So that happens super, super fast. Now keep in mind, I mentioned those cortical granules, and I said they really contain some important chemistry. This is all about what's called a slow block. This happens much slower. And the cortical granules are all going to go through the process of exocytosis. And they dump that chemistry out into the zona pellucida, that lucid zone, that clear zone. And the zona pellucida expands. It blows up in size. And so what it does is it's going to physically move any other sperm away. So let me go back to this diagram. First, fast block, sodium channels. Sperm don't want to interact with the membrane anymore. Second, slow block. Zona pellucida becomes really, really big, and everything out here gets pushed away. And while this is going on, you're ending prophase arrest. Once you've gotten yourself back to 46 chromosomes, you're back to a healthy diploid state. You go back through these. You dive into mitosis. So right back here, we've got fertilization at 0 hours. You can see all of the sperm that are involved. There's the one that's fertilizing, and then we go from 1 to 2 to 4 to 8 to 16 to 32. And morphologically, it starts to take shape, change shape, and we have a gut that starts to develop on the inside. And then we get to the world of implantation. There's your baby. Give it the better part of a year, let it gestate, and give birth through the dilated, hopefully, cervix and vaginal canal. And we're right back to where we started about 5 or 6 videos ago. So there it is. There is the human, male and female reproductive systems. It took a little bit longer than others because when we talk digestive in males, it's the same thing in females. But here we had to split it apart. So there you go. I will try and get to work on some metabolism and nutrition.